Good morning, geometry class. Looking at 6.1 properties and attributes of polygons. Give you a little summary here about the sections for each of the quadrilateral unit that we will be looking at. We'll try this way to provide you guys some additional information. So hopefully this goes well here. Looking at our properties and attributes of polygons, now the notes, my notes are on the Google Drive, so you can follow along with that as well. I've got my notes sitting right here that I'll be looking at. Just to start out with some basic information, noticing that you have sides of polygons. Poly, the first thing we think of octagon, which has 8 sides, hexagon, which has 6 sides, so on and so forth. Poly means many. Okay, so a manygon, it's an undefined number, which we then give a name to when we set up a more specific gon of that sort there. Diagonal is a kind of a new vocab word. You've seen it before, but it connects any two non-consecutive sides, as you see by the definition there. So like D to C is a side, D to C is a side, D to B would be a diagonal, D to A would also be a diagonal because they are non-consecutive sides. Identifying polygons, tell whether each figure is a polygon. If it is a polygon, name it by the number of sides. Now polygons have to be connected. Okay, question A here, it is connected. You see the little, that's a printing glitch on the right hand side there. It is a polygon, 5 sides, so a pentagon. B, crisscrosses, therefore it is not a polygon. And C, it is a polygon, 8 sides, named by an octagon. And if we look down at the questions below, 1A would not be because it's open. B is, C is not because you cannot have curved sides on a polygon. You have to have straight sides. So a regular polygon is one that is both equilateral and equiangular, meaning all of your side lengths and all of your angles are the same length. Now we really only have one regular polygon, and that is a square when we think about it. The rest of them can be made regular, but squares are always regular. Okay, so in that case right there, that's an octagon, but it's not a regular octagon. Squares are always the same for side lengths and the same for angles. Moving up to the top, we've got concave and convex. Two different vocab words here, concave quadrilateral and convex quadrilateral. I want you to think with concave as it caves in. Notice the caving in here of this side length caves inwards. Concave quadrilateral. Convex is what we would normally think of. If you think about mirrors, concave mirrors, convex mirrors, they cave in. They have a little bow to the inside. So we're talking about regular and irregular here, concave and convex. That is irregular because the sides are not the same length. It is convex. That is regular. All angles and side lengths are the same length. That is irregular because it is has many different angles. You first initial look and say, hey, that angle is the same as that angle is the same as that angle, which is true, but you also have these interior angles that are bigger than 90 degrees, okay, that you have to think about as well. Therefore, they're not all of the same. To find the sum of the interior angle measures of a convex polygon, it uses a little trick. It says draw all the possible diagonals from one vertex to the other. Okay, this creates a set of triangles. So this is a triangle. If we think about a triangle, we know the sum of the interior angles is 180 degrees. Well, if we split a quadrilateral in half, we have 2 triangles, which is 360 degrees. 2 triangles, 2 times 180 is 360. So on and so forth. 5-sided, 3 triangles, 540 degrees. A hexagon has 6 sides, but it has 4 triangles that's created by the diagonals. Therefore, it is 720 degrees. And we can do this math down here. It gives you this chart that you can follow along with, and then provides you the polygon angle sum theorem. The sum of the interior angle measures of a convex polygon with n sides is parentheses n minus 2 times 180. That's a very important formula you're going to want to have to jot it down. It'll also aid you in questions 10 through 13 on your 6.1 homework assignment. Questions 10 through 13. Up here, it then provides you a little extra practice on the examples. You can work through those if you, or follow along with those if you would like. Let's do 3 here, 3A here. It says find the sum of the interior angle measures of a convex 15-gon. So I'm going to pull up my whiteboard. Okay, we have a convex 15-gon. So we got 15. So let's think of our equation. N minus 2 times 180. N 15 minus 2 times 180, which is 13 times 180. Okay, and if we do that math, 180 times 10 is 1800. And 180 times 3 is 540. That's going to be 2,340 degrees. Now that's the sum of all of the interior angles. Let's say it's regular. Just for an example, if it's regular, that means all of the angles are the same length or same measurement. So we can take that 2340 and divide by 15 to figure out that each angle measurement here. I'm going to grab my calculator. Each angle measurement is 2340 divided by 15, which is 156 degrees. Okay, so each interior angle of a regular 15-gon. Now, I don't know how to draw a 15-gon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. As you can clearly tell, I need a whole lot more side lengths than what I've got there. It's a nice drawing. Each measurement of the interior angles will be 156 degrees. Okay, so that's one way to think about that. Find the measure of each interior angle of a regular decagon. Well, decagon is 10-sided. And one second here. So if we take our 10-sided gon, we take 10 minus 2 times 180. 8 times 180, which is 800, plus 640 is 1440. And we're going to divide that by 10 to figure out which each angle measurement is, and you get 144 degrees. So another example of finding individual angles of a regular shape. One cool thing moving into next is the exterior angle sum theorem, and it says the sum of the exterior angle measures, one angle at each vertex of a convex polygon. So no matter the shape, 10-sided, 12-sided, 100-sided, always is 360 degrees. If we look at this example, the angle measurements always add up to 360. The angle measures always add up to 360. No matter what shape you're working with, all these exterior angles always add up to 360 degrees. If we do our little math up here, we know this 7a plus 2a plus 3a plus 6a plus 2a has to add up to 360. 20a has to add up to 360. A has to equal 18. Okay, just a little bit of consistent mathematics approach when it comes to solving exterior angle measurements. Something to keep in mind. So, one last look at my notes here. Interior angle theorem, exterior angle sum theorem, so on and so forth. This is all covered in your 6.1 assignment. If you have any questions, let me know. But you should be able to go ahead and get started on that. Thank you.